So let's now try to answer exercises on rational function. So again, the competencies that we have for rational function are the following. Find the domain of a rational function in set builder and interval notation. Find the intercepts and zeros of a rational function. Determine the vertical, horizontal, slant asymptote of a rational function. So let's just recall, rational function is a function in the form of f of x equals p of x over q of x, for q of x should not be equal to 0. Again, q of x should not be equal to 0 because if q of x is equal to 0, the function will be undefined. Domain, all real numbers except the x values that make the denominator equal to 0. Intercepts, we look for the y-intercept by evaluating f of 0, or we let x be equal to 0. X-intercept, or the zeros of the function, we solve for p of x, or your numerator equated to 0, for x in the domain of. Next, vertical asymptote is a line x equal a. It occurs at any x values that make the denominator 0 after all common factors have been divided. X equals a. Horizontal line is your horizontal asymptote in the form of y equals p. You have the x-axis, or y equals 0, as your horizontal asymptote when the degree of the numerator is less than the degree of the denominator. So again, degree of the numerator is less than the degree of the denominator. Horizontal asymptote other than the x-axis occur, which is the ratio if you have equal degree of the numerator and the denominator. The horizontal asymptote is the ratio of the leading coefficient. And then there is no horizontal asymptote if n is greater than m, meaning the degree of your numerator is greater than the degree of your denominator. Okay, let's proceed. Next. So you have the slant asymptote y equals mx plus b if the degree of the numerator is 1 more than the degree of the denominator, meaning degree of the numerator minus the degree of the denominator is equal to 1. Then you have a slant asymptote. How do we look for the slant asymptote? We simply divide the numerator by the denominator. The quotient corresponds to the equation of the line of your slant asymptote or oblique asymptote. Please remember, there can only be one horizontal asymptote or oblique asymptote, but never both. Again, there can only be one horizontal asymptote or oblique asymptote and never both. So your task is to find the domain, the intercepts, and the asymptotes of the following rational function. So you have f of x equals 2x squared minus 18 all over x squared plus 3. Number 2, f of x equals x squared plus 1 all over x squared plus x minus 2. Number 3, f of x equals x minus 2 all over x squared minus x minus 2. Number 4, f of x equals x squared minus 3x minus 4 all over x squared minus 6x plus 8. And number 5, x squared minus 4x minus 5 all over x minus 3. Again, we're asked to find the domain in set builder interval notation, the intercepts, and the asymptote. Okay, so let's start with the first one. So first, what will be the domain of f? So the domain of f is x such that x, so equating the denominator to 0, you have x squared plus 3 equals 0, x squared equals -1, x equals the square root of -1, positive, negative I. So meaning, the only value that will make the denominator equal to 0 is I, so that means it's a set of all real numbers. So that's the set builder. So interval notation is from -infinity to +infinity. So meaning there is no possibility that your denominator will be 0. Okay, so let's move to the next one. So we factor the numerator. So this is 2 times x squared minus 9 all over x squared plus 3. So this is 2 times x plus 3 times x minus 3 all over x squared plus 3. So let's look for the intercepts. So what is our y-intercept? Let's start first with the y-intercept. So we let x be 0. So if this is 0, you just have -18 over 3. So the y-intercept is equal to -6. So you have 0, -6. How about our x-intercept? So x-intercept, we equate the numerator to 0. So you just have x plus 3 equals 0. So you have positive and -3. So you have two zeros. So that is 3, 0 and -3, 0. Asymptote, vertical asymptote. So the vertical asymptote, so we equate the denominator. So there's none. Because this is the same with equating x squared plus 3, you will have an imaginary number. Horizontal asymptote, let's check. What's the degree of your numerator? What's the degree of your numerator? It's 2. Degree of the denominator is also 2. So that means it's equal. So it's the ratio of the coefficient. So the horizontal asymptote is y equals 2 over 1 coefficient. So this is 1. So divide. So you have 2. So y equals 2. So that's it. We're able to look for the domain, the intercepts, the vertical asymptote, and the horizontal asymptote. Okay, let's proceed to the second one. So the next given is f of x equals x squared plus 1 equals to x squared plus x minus 2. So we factor first so that we can easily get the other parts. So numerator is just x squared plus 1. Denominator, this is x plus 2 times x minus 1. Am I correct? X plus 2, 2x, x minus 1. Okay, so let's identify the domain first in set builder notation. So that is x such that x should not be equal to equating x plus 2, you have negative 2 and positive 1. So in interval notation, this is from negative infinity until negative 2, union negative 2, 1, union 1 to positive infinity. So that's the interval notation. Next, let's have the intercepts. So y-intercept is just this one, letting x be equal to 0. So that is equal to negative 1 half. So you have 0, negative 1 half. X-intercept, equating the numerator to 0. So this time, that's x squared plus 1. So if we equate the numerator to 0, what will happen? So that becomes x squared plus 1 equals 0, x squared equals negative 1. So same with the other example, x equals positive, negative, the square root of negative 1. So it's imaginary. The x-intercept is imaginary. So therefore, what do we mean by that one? Since the x-intercept is imaginary, we don't have any x-intercept. Okay, so that's the intercept. So let's have the asymptote, vertical asymptote. So vertical asymptote from the denominator equated to 0. So you have 2x equals negative 2 and x equals 1. Horizontal asymptote, comparing the degree of the three, rather the numerator and the denominator. So you have, what's the degree of your numerator? So the degree of the numerator is 2, denominator is 2, coefficient is 1, 1. So horizontal asymptote is y equals 1 over 1 or 1. So that's it for the second function. Next, I hope you're getting the ways on how to look for what is asked in the problem. Okay, so we equate, we get the factor. So x minus 2 all over x minus 2 times x minus 1, or rather x plus 1. Okay, so here we have the simplest inequality, 1 over x plus 1. So you have a common factor, x minus 2, x minus 2. So we have to take note of that one. But again, taking note of the common factor, let's find the restriction, or rather the domain. So the domain of the function is still x, such that x is not equal to positive 2 and negative 1. So in interval notation, that is from negative infinity to negative 1, union negative 1, 2, union 2 to positive infinity. So this is for the interval notation, and this is for the set builder notation. Okay. So let's have the x-intercept, or rather y-intercept first. So y-intercept, since this one will be canceled out, so you just have 1. 1 over 0 plus 1. So y-intercept is 1. So again, y-intercept will let x be 0. So it's 1. So you have 0, 1. X-intercept, equating the numerator. So is 1 equals to 0. So there's none. Asymptote. So we have the vertical asymptote. So that is numerator. This one is canceled out. So you just 1. So we don't have any vertical asymptote. How about horizontal asymptote? So degree of the numerator is less than the degree of the denominator. Okay, so you have y equals 0. It's less than. So domain intercepts asymptotes. Here, since we have the one that is being cancelled out, we have a whole. So what is the whole for this one? The whole is at x equals 2. So what is that particular point? So how do we do that? So simply substitute x equals 2 to the simplest inequality. So we substitute 2 f of x equals 1 over x plus 1. Substituting, you have 1 over 2 plus 1, 1/3. So the whole is at 2, 1/3. So if there's a whole, you have to indicate that particular whole in your solution. So meaning in the graph of this function, you have an open circle at the point 2, 1/3. Okay. So second to the last example, x squared minus 3x minus 4 all over x squared minus 6x plus 8. So first, let's factor the numerator and the denominator. So this is x minus 4 times x plus 1 all over x minus 4 times x minus 2. So again, if you can observe, you have a common factor at x minus 4. So the simplest function is x plus 1 over x minus 2. So let's identify the domain. So what is the domain of the function f in set builder notation? So it's still x such that x should not be equal to positive 4 or positive 2. So the domain of f in set builder notation is positive 4 or positive 2. So from negative infinity to 2, union 2, 4, union 4 to positive infinity. So let me check that one. Let's plot it on a number line. So you have, this is 2, this is 4. So except 2, except 4. So negative infinity to 2, 2 to 4, between 2 to 4, and 4 to positive infinity. Okay. Next. So intercepts. What is our x-intercept or y-intercept? So y-intercept, we let x be 0. You just have negative 1/2, substituting 0, negative 1/2. So 0, negative 1/2. X-intercept is, equate the numerator. So you have negative 1. So negative 1, 0. Vertical asymptote. So asymptotes. So vertical asymptote, since this one will be cancelled, it's just x equals 2. Horizontal asymptote. So equal degree. Numerical coefficient is 1. So you have y equals 1. So that's it for number 4. Let's proceed with the last example. So the given is x squared minus 4x minus 5 equals x minus 3. Can we factor the numerator? Yes, it's x minus 5 times x plus 1 all over x minus 3. So let's identify now the domain of the function. So it's just x such that x should not be equal to 3. In set builder notation, that is negative infinity to 3 union 3 positive infinity. Intercepts. So y-intercept will let x be 0. So it will just be negative 5 over negative 3. So that's 5 over 3. So you have 0, 5 over 3. X-intercept, we equate the numerator to 0. So you have x minus 5 equals 0. X plus 1 equals 0. So x equals 5. X equals negative 1. So you have 5, negative 1. So 5, 0, negative 1, 0. Next asymptote. Let's have vertical asymptote. So the vertical asymptote, denominator to 0. There's no common factors. Equate the denominator. So you have x equals 3. Horizontal asymptote. Check the degree is greater than the denominator. So that means there's no asymptote. But checking at the degree is of the numerator is 1 less than the denominator. So we have a slant asymptote. So again, how do we get a slant asymptote? So for us to get the slant asymptote, all we have to do is to divide the numerator by the denominator. So let's divide x squared minus 4x minus 5 by x minus 3. So you have x squared, x times negative 3x. So you have positive, negative x minus 5. So minus 1, negative x, negative plus 3. So this is negative, positive, negative, so negative 8. So you have the quotient in the form of mx plus b. So this is our slant asymptote. The slant asymptote is a line, so y equals x minus y. Disregarding the remainder, you have y equals x minus y. So that's it on how to find the domain in set builder and interval notation, the intercepts. Your y-intercept, you let x be 0. For your x-intercept, we equate the numerator to 0. And then afterwards, checking the numerator and the denominator, you can look for the vertical asymptote by equating the denominator to 0 after all the common factors have been cancelled out. Horizontal asymptote as well as slant asymptote, comparing the degree of the numerator and denominator.